Algorithm analysis. To learn this algorithm analysis, first we must know what is the algorithm. Yes, what is algorithm? Algorithm is nothing but it consists of the set of instructions, and these instructions these are arranged in a particular order to perform certain particular task. That is nothing but the algorithm. Then, which are the characteristics of algorithm? Yes, it is right. That is the stepwise instruction distribution. But only stepwise instruction is not the algorithm. That instructions must be arranged in a sequential or in a particular order. And that algorithm must be designed, must be right to perform certain tasks. Okay, idea behind a program, yes, it is also right, but again that is present in the form of instruction, and that instruction must be in a particular order. Arrange must be in a particular order, and that must be to perform certain tasks. Yes, Shreya, it is right. It is a finite list of instructions. These are used to perform a task. Now, what are the characteristics of algorithm? That algorithm, it should be finiteness, it should be definiteness, it should be effectiveness, it should having certain input and output. Okay, means these are the characteristics of algorithm. Now, what is the finiteness? The finiteness is nothing but whatever the steps are present in the algorithm, the number of steps, it should be finite. It should be finite. If it goes into the infinite, then that is not a algorithm. That is not the characteristics of algorithm. Okay, then definiteness. Definiteness means each step must be clear and unambiguous. Unambiguous means it does not have the more than two meaning. It should be unambiguous. Each and every instruction, it should be clear and unambiguous. Then effectiveness, every step, it must be basic and the essential. Input, it takes the zero or more input. See, why zero or more input? Because there are certain algorithms where input is not required. For example, suppose I want to write a program to display my name and address. Okay, in C language. Then what happen? I simply use the printf statement, and in that printf statement I write my name and address and display it. Means here this program then at that time does not take any input. Means an algorithm, it should take either a zero or more input. But in case of output, it generates one or more output. That is, there should be at least one output for an algorithm. That is, these are the characteristics of algorithm. For example, see here. Here, it is a simple algorithm to calculate the area of rectangle. That is, what is the area of rectangle? Area of rectangle is nothing but length into the breadth. Then, what is the first step here? Start. Then, second step, declare length, breadth, and area variables. That is, to perform this program, to write a program to find out the area of rectangle, it is necessary to declare these three variables: length, breadth, and area. Then input the length and breadth. Means here we are accepting the input. Then we are using set area equal to length into breadth. Means we are calculating this, whatever the value of length. Suppose here at time, that is in, it is inputted as a 5, length and breadth is 4. Then this calculation 5 into 4 is performed, and then that 20 it is assigned to the area, and then display area. Means, see here, what are these characteristics here? Finiteness, the number of steps should be finite. Yes, number of steps in this algorithm, these are finite. Then definiteness, each step must be clear and unambiguous. Yes, here it is, each and every step is clear. We can easily understand that what is that first step is start, then we are declaring the variables, then we are inputting the values for that variables, and perform the set is nothing but here we are performing the calculation and then we are displaying. Okay, and then input, it takes 0 or more input, and output, it generates 1 or more output. Okay, these are the characteristics of the algorithm. Now, whenever we want to find out, we want to analyze the algorithm, means what? We want to check the performance of algorithm. Then how to check that performance of the algorithm? See here, the performance analysis of an algorithm, it can be evaluated by, does it perform the desired task? Means, for what purpose we are writing that algorithm, that task is satisfied, that task is performed by that algorithm or not. Yes, then in this way we are checking the performance of the algorithm. Then again, it works according to the specification. Specification means what? Whatever the specified initially. What is that specification? Requirement specification. You have already learned in software engineering also. Whenever we want to, that is, develop a software, then first it is necessary to design the SRS, software requirement specification, and in that SRS all these, what that actually that software it should perform, that are specified, and according to that SRS we are developing the software. Then same way here, whenever we want to analyze the algorithm, performance of the algorithm, means it works correctly or not, it is readable or not, then how to check that? Okay, does it contain the documentation about how it works? Is it readable one? Is it it works according to specification? Is it satisfy the whatever the needs of that particular algorithm? Needs of the algorithm is what? For what purpose we are writing that algorithm? It works according to that specification or not? Then how to, but here, okay, these are the, in this way we can measure the performance of the algorithm. But only is it sufficient? No. Only to check it work according to specification, is it readable or not, is it documentation is present or not, it is not possible. Hence, that performance of the algorithm, that is necessary to find out. And how to find out that? Again, why there is a need of the algorithm analysis? Okay, before that, this term, the analysis of algorithm, it was invented by Donald Knuth. And then this, why there is a need of the algorithm analysis. See here, for example, suppose consider a searching technique. In searching technique, there are mainly two searching techniques are there. One is the linear search and another one is the binary search. Now, see here, there are two algorithms are there. Both algorithms, these are for the searching purpose. Then, which one is the best one? Okay, it is necessary to find out that which algorithm is best one. But then how can we decide that linear search is best one and binary search is best? How can we decide? Then these are decided by using the how much time it required in terms of the space and the time complexity. How much memory size is required and how much means storage is required for the implementation of that algorithm. Based on that, we can find out, we can check that that particular algorithm is the best. Means for that purpose, there is a need of the algorithm analysis. That is considered sorting. Okay, suppose there are 10 numbers are there. There is one array having the 10 numbers and we want to sort that. Then in sorting, there are various sorting techniques are there. There is a bubble sort is there. You may have heard this word bubble sort. Okay, there is a insertion sort is there. There is a selection sort is there. There is a merge sort is there. There is a quick sort is there. Then which sorting technique we have to use? Okay, it is necessary to analyze that, and for that purpose there is a need of the algorithm analysis. And this algorithm analysis is nothing but it is the process of analyzing the problem solving capability. Then problem solving capability means what? In terms of what we are checking that problem solving capability in terms of the time and size. That how much time and how much size is required for the implementation. Based on that, then we are deciding that algorithm is the best or not. That is, see here the examples these are given, that algorithms these are different, means to perform the same task, to perform the sorting, there are various algorithms are there. To perform the searching, there are various algorithms are there. Again, to find out the shortest path, there are again various algorithms are there. Then which algorithm is best? These algorithms, these are different from one another. Although the objective of this algorithm is same, that objective is to find out the shortest path, but there is a different algorithm. There is a Dijkstra's algorithm, there is a Kruskal algorithm, means there are various algorithms are there. Same way to perform, our objective is same, that is to find perform the sorting of a number, but there are various algorithms are there: insertion sort, selection sort, bubble sort, merge sort, quick sort, heap sort. Then which sorting technique is best? How to find out that? Or whatever the number of comparisons, number of operations performed